Good morning, students.
Good morning.
All of you, please switch on your videos. Those who are not facing any kind of network issues and all, please switch on your videos. Here I can see only 1, 2, 3, 4, 5, 6 faces. What about others? Please switch on your videos. Okay. So in our last class, we discussed about the vector addition by analytical method. Vector addition by analytical method. And we derive an expression for calculating the direction and magnitude of the vector R, the resultant vector R, with the help of law of cosine. Then Malaviga Vibin, what is the equation for calculating the magnitude of resultant vector R according to law of cosine? Equation for calculating the magnitude of resultant vector R. Malaviga, Vibin. Same question to Eva. What is the equation for calculating the magnitude of resultant vector R? Again, the same question to Merrill.
Alpha is equal to tan raised to
Equation
minus
for calculating magnitude of resultant vector R, not the direction. Shabarinath.
A square plus b square plus 2ab cos theta. Under the
Okay.
root.
Okay, if we have two vectors A and B, then the magnitude of the resultant vector is given by R is equal to square root of A square plus B square plus 2ab cos theta. So instead of A and B, here we are practicing with the two vectors P and Q. Then the magnitude of the resultant vector is given by R is equal to root of P square plus Q square plus 2p cube cos theta. Then the next question is to Emmeline. What is the equation for calculating the direction of the resultant vector?
tan inverse into q sine theta divided by p plus q cos theta.
Yes, the direction of the resultant vector alpha is equal to tan inverse q sine theta divided by p plus q cos theta. Okay, where alpha is an angle. So if we know the angle and that of the magnitude of the vectors, then we can easily say the direction of the resultant vector with respect to the magnitude of the vectors. So that is what we were discussing in our last class, and some special cases also. If the angle theta is equal to 0, what about the magnitude of the resultant vector? Now ring. If the angle theta is equal to 0, what is the equation for magnitude of resultant vector becomes? Same question to Gaya.
R is equal to P plus Q.
R is equal to P plus Q. Okay, very good. Then what about the direction of the resultant vector? Alan Joshi. If theta is equal to 0, direction of resultant vector?
Ma'am, 0.
It is equal to 0. Alpha is equal to 0. If the angle theta is equal to 0 degree, then the direction of the resultant vector become equal to 0. Then the second case, Pooja, if theta is equal to 180 degree, what is the equation for calculating the magnitude of resultant vector?
R is equal to P minus Q.
R is equal to P minus Q. Then very good. Devika Girish. What about the direction of the resultant vector if theta is equal to 0? If theta is equal to 180 degree, then the direction of the resultant vector is also equal to 0. So in the both cases, if theta is equal to 0 degree or theta is equal to 180 degree, the direction corresponding to the resultant vector becomes equal to 0. So let us see a problem regarding with this. Okay, so here you have a question. The magnitude of two vectors are equal and opposite to the magnitude of their result. Okay, not equal and opposite. The magnitude of two vectors are equal and which is equal to the magnitude of their resultant. Then what will be the angle between these vectors? The magnitude of two vectors are equal and which is equal to the magnitude of their resultant. Then what will be the angle between these vectors? Magnitude of two vectors are equal and is equal to the magnitude of their resultant. Then what will be the angle between these two vectors? You can expect the questions like this from this chapter based on the law of sine, law of cosine. The magnitude of two vectors are equal and is equal to the magnitude of their resultant. Then what will be the angle between these vectors? Any idea? Suppose here we consider the two vectors. Okay. The magnitude of two vectors are equal. They are not saying anything about the direction. They are saying about the magnitude. So in the question, they give an idea about the magnitude of two vectors. They are not mentioning anything about the direction of the two vectors. If they are mentioned the direction about the two vectors, then we can say that they are equal to 0. But here they are giving magnitude of two vectors are equal to are equal. So suppose we are consider the two vectors, vector P and vector Q. So here we consider the two vectors, vector P and vector Q. The magnitude of these vectors. So we can take the magnitude of vector P as P. Similarly, the magnitude of vector Q is taken as Q. Okay. So according to our condition, the magnitude of two vectors are equal. That is, here we consider the two vectors, vector P and vector Q. But these two vectors are not equal, their magnitude. So the magnitude of vector P is taken as symbol, the letter P, and the magnitude of vector Q is taken as simply the letter Q. Then they say that the magnitude of these two vectors are equal. That is, P is equal to Q. Magnitude of the two vectors are equal and which is equal to the magnitude of their resultant. Suppose if vector R is the resultant of these two vectors, vector P and vector Q. We are doing a problem like that. We are deriving the expression in the form. Suppose we are considering the two vectors. For example, here we have vector P with the magnitude P, vector Q with the magnitude Q. Then the resultant is represent the diagonal. This is represent vector R with the magnitude R. So here, according to our condition, we have two vectors, vector P and vector Q, but their magnitudes are equal. So here we consider the vector P with a magnitude P and vector Q with a magnitude Q. The resultant is represented by vector R. Its magnitude can be taken as R. Then according to our condition, we can take here P is equal to Q is equal to magnitude of the resultant vector, that is R. We have two vectors, vector P and vector Q. with the magnitude P and Q respectively. Then again, according to your condition, the magnitude of these two vectors are equal to the magnitude of the resultant vector. The resultant vector of vector P and vector Q are vector R. Then the magnitude of the resultant vector is simply the letter capital R. So according to your condition, we can write P is equal to Q is equal to R. Then what we want to calculate here? Then what will be the angle between these vectors? What will be the angle between these vectors? What is the equation for calculating the magnitude of a resultant vector? According to law of cosine, what is the equation for calculating the magnitude of a resultant vector?
Root of p square plus q square plus 2p.
Yes, R is equal to root of p square plus q square plus 2pq cos theta. 2pq cos theta. This is the equation for calculating the magnitude of a resultant vector. So here we don't need to find out the magnitude. Here we want to calculate the angle theta between these two vectors, vector P and vector Q. So in order to find out the angle theta between these two vectors, vector P and vector Q, here the condition is the magnitude between these vectors, that is P and Q, are equal, which is equivalent to that of the magnitude of the resultant vector. So we can write P is equal to Q is equal to R. And for the easiness of the calculation, we can equate all these are equivalent to an unknown variable X. Okay. So here for the easiness of calculation, we taken this magnitude of vector P, which is equal to magnitude of vector Q, which is equal to magnitude of the resultant vector R. All these are equal to a variable that is given by X. Okay. Now, what about our equation becomes? So substitute the value of X here into this equation. So the equation become, instead of R, here we can substitute S X. Very good. X is equal to root of, instead of P, here we have again X square plus, here the Q is also equivalent to X. So again X square plus 2pq cos theta. So here P is equal to X, Q is equal to X. So we have 2x into cos theta. Okay. In order to replace this root, we can take this is as x square. X square is equal to x square plus 2x square cos theta. 2x into x becomes 2x square cos theta. Here we square the LHS. X square is equal to, then the root becomes gone. So it becomes x square plus 2x square cos theta. Or we can write x square is equal to, what is x square plus x square?
Square.
2x square. So here we have 2x square plus 2x square cos theta. Or we can write x square is equal to, here which term is common in these two terms in the RHS? 2x square is common, so we can take it outside. So 2x square into, what is left?
1 plus cos theta.
1 plus cos theta. So the equation becomes x square is equal to 2x square into 1 plus cos theta. Again, what is 1 plus cos theta? Just rearrange the equation. 1 plus cos theta is equal to,
9 theta.
yes, x square divided by 2x square. Here we brought this 2x square into LHS, so it becomes 1 plus cos theta is equal to, or just rearrange the equation. X square by 2x square is equal to 1 plus cos theta, or we can write 1 plus cos theta is equal to x square by 2x square. Here this x square is cancels from the numerator and the denominator. So equation becomes 1 plus cos theta is equal to 1 plus cos theta is equal to 1 by 2. 1 plus cos theta is equal to 1 by 2, which implies cos theta is equal to, what is cos theta?
1 by 2 minus
1 by 2 minus 1. Cos theta is equal to 1 by 2 minus 1. That is cos theta is equal to, what is 1 by 2 minus 1?
minus 9.
Minus half. Cos theta is equal to minus half. So here we want to calculate the angle between these vectors, which implies theta is equal to, cos theta is equal to minus half. Then theta is equal to, take the cos to RHS. So it becomes whenever we take the cos, the term cos taken to RHS. So it becomes cos inverse minus 1 by 2. Cos inverse minus 1 by 2. What is cos inverse minus half? Cos inverse minus half is equal to 120 degree. You can take the clerk's table to exam hall, so you don't need to worry. You can easily find these values from the clerk's table. So theta is equal to cos inverse minus half, that is equal to 120 degree. So what is the angle between the two vectors, vector P and vector Q? What is the angle between them? 120 degree. This is the answer. So the question is this: the magnitude of two vectors, not the direction, the magnitude. The magnitude of two vectors are equal, and which is equal to the magnitude of their resultant. Then what will be the angle between these vectors? Okay, so once again, we can go through all the steps. First of all, we are consider the vectors. Vector P, its magnitude is equivalent to P. Then one more vector, vector Q, its magnitude is equivalent to Q. Okay. And according to our condition, the magnitude of these two vectors are equal. That is, P is equal to Q, which is equivalent to their resultant vector, magnitude of the resultant vector. Here the resultant vector is represented by vector R with the magnitude R. So according to our condition, we can write P is equal to Q is equal to the magnitude of the resultant vector, that is equal to R. For the easiness of calculation, here we are equate all these magnitude is equal to another variable, that is X. Then according to the equation for calculating the magnitude of vectors, that is by law of cosine, we know that R is equal to root of P square plus Q square plus 2PQ cos theta. 2PQ cos theta. Or we can write R square is equal to, if R is equal to root of P square plus Q square plus 2PQ cos theta, which implies R square is equal to P square plus Q square plus 2PQ cos theta. Then we just substitute all the values here. Here we know that P is equal to Q is equal to R equal to the another variable X. So it becomes x square is equal to, here p is also equivalent to the variable x square, q is also equivalent to x square, plus 2pq cos theta, 2 into x cos theta. So here x square is equal to, x square plus x square becomes 2x square plus 2x into x, that is also 2x square cos theta. So in this equation, this 2x square term is common, so we can take it outside. It becomes x square is equal to 2x square into 1 plus cos theta. Then what is the next step? We bring the 2x square into LHS. That is x square divided by 2x square is equal to 1 plus cos theta. Here we can cancel this x square and x square from numerator and denominator. So it becomes 1 by 2 is equal to 1 plus cos theta. Or we can write 1 plus cos theta is equal to 1 by 2. Which implies cos theta is equal to 1 by 2 minus 1. That is cos theta is equal to minus half, which implies the angle between the two vectors, vector P and vector Q, is given by theta is equal to, take the cos term to the right hand side, it becomes cos inverse minus half. The value of cos inverse minus half you can obtain from the class table, that is equal to 120 degree. So this is the answer. Is it clear?
Yes, ma'am.
Yes.
Okay. All right. So that's about the law of cosine. Law of cosine in vector addition using the analytical method. Just similar to that of this law of cosine in vector addition using analytical method, we have one more law is there. That is what is known as law of sine. Okay. So all of you write the next heading, law of sine. Similar to this law of cosine, we have one more law in vector analytical method. That is what is known as law of sine. Vector addition using analytical method, put a hyphen and write law of sine. Vector analytical method using law of sine. In order to explain the law of sine, here we consider the same figure. We take two vectors, vector P and vector Q, such that these two vectors with the magnitude P and Q represent the two adjacent sides of a parallelogram. Then what about the resultant vector according to parallelogram law of vector addition? What is the resultant vector here?
Root of p square plus q square plus 2pq.
Yes, it represents the diagonal. The resultant vector is the diagonal of the parallelogram, that is also starting from the same point. Okay, so you can write the conditions once again. Here we consider the two vectors. Here we consider the two vectors, vector P and vector Q. Here we consider the two vectors, vector P and vector Q, with the magnitudes P and Q respectively. Here we consider the two vectors, vector P and vector Q, with the magnitudes P and Q respectively. Which is inclined at an angle theta. Which is inclined at an angle theta. Then By parallelogram law of vector addition, then
Need the
yes, Adulya.
Can you repeat from
Okay.
starting?
Here we are considering the two vectors, vector P and vector Q, with the magnitudes P and Q respectively, which is inclined at an angle theta, which is inclined at an angle theta. Then by parallelogram law of vector addition, the resultant vector is given by the diagonal of the parallelogram, which is also starting from the same point. Here the resultant vector is represented by the diagonal of the parallelogram, which is also starting from the same point. Now, in order to derive the equations of law of sine, we here we draw a line. From the point A to the resultant vector. This is what is the change that we are made here in order to derive the law of sine. In order to derive the equations for law of sine, here we draw a line to the resultant vector. Here we draw a line perpendicular to the resultant vector, vector R. In order to obtain the equations for law of sine, here we draw a line from point A perpendicular to the resultant vector, vector R, and chose an angle beta, and here we choose an angle beta between the resultant vector and vector Q. And chose an angle beta between the resultant vector and vector Q. So while deriving an expression for resultant vector using law of cosine, we are starting the derivation by considering an angle alpha between the resultant vector and that of the vector P. So here, while deriving an equation for law of sine, we choose an angle beta between the resultant vector R and that of the vector Q. Okay, so here we choose an angle beta between the resultant vector and that of the vector Q. All the others are same. So here we consider the two vectors, vector P and vector Q, which is inclined at an angle theta, such that according to parallelogram law of vector addition, the diagonal of this parallelogram is represent the resultant vector. It is given by vector R. In order to find an expression for magnitude of the resultant vector, here we are make an extension from OA and draw another line that is perpendicular from point B, which is meet at a point D. All the other considerations will be the same. So here we get another triangle ABD. But here, in order to derive the expression for law of sine, we draw a line from the point A perpendicular to the resultant vector R, and we choose an angle beta between the resultant vector R and that of the vector Q. Okay, so once again here we can recollect what are the angles between the vectors. So here we have, now we have three angles are there. One is the angle between the two vectors, vector P and vector Q, and other is the angle between vector R and vector P. Now we have a new angle, that is the angle between vector R and that of the vector Q. Okay, so suppose we can consider all these angles now. So it becomes here angle between vector P and vector Q. Here angle between vector P and vector Q is, what is the angle between vector P and vector Q?
Theta.
Theta. Here the angle between vector P and vector Q is theta degree. What is the angle between vector P and resultant vector? Angle between, yes, vector R and vector P is taken as alpha. In our previous case, we take the angle between resultant vector, vector R, and that of vector P as alpha. And what is the angle between resultant vector R and vector Q?
Beta.
It is beta. Okay. So here we have three different angles are there. One is the angle between two vectors, vector P and vector Q. Then alpha, alpha is the angle between resultant vector and that of the vector P. And the third one is beta. Beta is the angle between resultant vector, vector R, and that of the vector Q. Now consider triangle ODB. Consider triangle ODB. Consider the triangle ODB. From triangle ODB, find, that is triangle ODB. I will show this with the help of triangle ODB, the same triangle that we are used in the previous case in order to find the BD and all. Okay. From triangle ODB, what is sine alpha represent? Sine alpha. Consider triangle ODB. Sine alpha is equal to sine alpha. Sine alpha is equal to, what is the equation for calculating sine alpha? Opposite side divided by hypotenuse. So from this triangle ODB, find an expression for sine alpha. Sine alpha is equal to opposite side divided by hypotenuse. What is the opposite side here?
BD.
BD. Hypotenuse?
R.
Resultant vector R, that is OB. Okay. So here we have sine alpha is equal to opposite side divided by hypotenuse, that is BD divided by OB. Or we can write Sine alpha is equal to BD divided by R, resultant vector R, which implies BD is equal to, what is BD? Yes, it's right. Unmute and say.
Sine alpha into R.
Yes, or we can write R sine alpha. Here we are not take the vector form, take the magnitude only. So sine alpha is equal to BD divided by R, which implies BD is equal to R sine alpha. So from triangle ODB, we find an expression for sine alpha. Sine alpha is equal to opposite side divided by, this is opposite side divided by hypotenuse. So from the figure, we can say that sine alpha is equal to BD by OB, or sine of alpha is equal to BD by OB is represents our diagonal. That is our resultant vector that is taken as R. So we can write BD is equal to R sine alpha. So put this is our equation number 1. Now consider the triangle OAE. Consider the triangle OAE. Consider the triangle OAE. E means here. Here we draw a line from point A to the resultant vector. It is intersect at this point and we can give a name as E. OAE. From the triangle OAE, what is sine alpha represents? Sine alpha. Again, we are going to find out the sine alpha from the triangle OAE. Here also we have the formula sine alpha is equal to opposite side divided by hypotenuse. Sine theta is equal to opposite side divided by hypotenuse. Here we have the angle alpha. Opposite side divided by hypotenuse. So sine alpha is equal to, what about the opposite side?
A.
AE divided by hypotenuse.
Here.
Yes.
P.
P. Here in this triangle OAE, the opposite side is represented by AE divided by OA. AE divided by OA. Which implies sine alpha is equal to AE divided by OA is the vector P with the magnitude equal to P. So here we get sine alpha is equal to AE divided by P, which implies AE is equal to P sine alpha. This is our equation number 2. You don't need to study all these entire derivation steps. We only need to study the final equation. But you must know from where this final equation is obtained. That is why we follow all these steps. So here sine alpha is equal to AE by P, which implies AE is equal to P sine alpha. That is our equation number 2. Now we are consider our third triangle. Consider triangle ABE. Consider triangle ABE. Consider the triangle ABE. From the triangle ABE, find sine beta. Sine beta. Sine beta is equal to, here also we have opposite side by adjacent side. Sine beta is equal to opposite side divided by hypotenuse. That is sine beta is equal to, from the figure, can you find out the opposite side and hypotenuse?
A by AB.
AE by
AB.
yeah, AE by AB, right? Sine beta is equal to AE divided by AB. Or we can write sine beta is equal to AE divided by, what about the value of AB?
Q.
Yes, it is the vector Q with the magnitude equal to Q, which implies AE is equal to Q sine beta. AE is equal to Q sine beta. This is our equation number 3. Okay. So here we get 3 equations from 3 triangles. So first of all, we are considering the triangle ODB. From triangle ODB, we get BD is equal to R sine alpha. This is our first equation. Then from the second triangle OAE, again we get AE is equal to P sine alpha. Then from our third triangle, triangle ABE, we get AE is equal to Q sine beta. So AE is equal to Q sine beta. And here we have AE is equal to P sine alpha. Okay, is there any other equations are there? No, right? Now, just observe the equation number 2 and equation number 3. Equation 2 and equation 3. So once again, we can recollect all the equations. Then we can observe and compare all these equations. What is our first equation? First equation.
BD is equal to R sine beta.
BD is equal to R sine alpha, right?
Sine alpha.
Second equation.
A is equal to P sine alpha.
A is equal to P sine alpha. Third equation.
A is equal to Q sine beta.
Q sine beta. This is our third equation. So here we have 3 equations are there. Now you just observe the equation number 2 and 3. What is similarity you can find? Compare the equation 2 and 3.
A sine alpha is equal to Q sine beta.
Yes, here the LHS of these 2 equations are same. Okay, sorry, it's a time. Okay, children, you don't need to worry. I know this is a new concept and lots of triangles are there. We can make it is more simple. You only need to concentrate the final equation. Okay, so we can